You have to be very careful when you talk about work. In addition to worrying about the numerical value and the sign convention, you have to specify the system or the environment that the work is acting on. For example, you could say an applied force does 12 joules of work on a box, so the box is your system. Or you could have gravity, which could be part of the system, or it could be your environment, doing -5 joules of work on a box. There you go, you're saying what you're doing the work on that is being raised up. The following statement has something wrong with it. What is missing? The statement is an external force does 6 joules of work. We have not mentioned what it is doing the work on, so that is not a valid statement. Net non-zero work can only be done to a system by an external force. This is a force from the environment outside the system. For example, if we have a box sitting on a table and I come along and push the box, I can increase the energy of the box. It now has kinetic energy. It's moving. That means I'm doing net non-zero work on the box. The question is, why are none of the internal forces increasing the energy of the box? For example, all the box molecules are moving about and colliding with each other all the time. Doesn't that involve an increase in energy? The molecules are certainly exerting forces on each other, and they are certainly causing each other to move, so that would seem that they're doing a net work so that the energy of the box should increase. We invoke Newton's third law to explain this. Every time a molecule in the box strikes another molecule, it certainly exerts a force on it and it moves. However, by Newton's third law, the second molecule exerts an equal and opposite force on the first one. Thus, the work done internal to the system equals 0. It all cancels out. Thermal energy complicates this picture, but as stated earlier, we will not be considering that in this unit.